Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for joining this session. Inshallah, we will start new chapter which is related to magnet. But before discussing about the magnet, let me show you some example related to the magnet itself, the application in our daily life. The first one is this. Maybe you know what is the name for this transportation. Like in Japan, we have Shinkansen, the other country having the other name for this one. But in general, we have the name for this one as the maglev, kereta maglev. And the fact for this one is it can run around 600 km per hour. If we want to compare, for example, if we ride our motorcycle, it is around 80 km per hour or 100 km per hour. So it is very fast because between the rail and also the train, they use the magnet as to minimize the friction between the road and the train. The second application, maybe all of us also know about this one. It works while we turn on this machine, it will become electromagnet, and if we turn off, it suddenly become the regular iron or regular thing that cannot attract the iron. For this one, we call that one as a scrapyard magnet or alat penarik besi tua. The point is in here. The next thing, both of them are not familiar with us because, maybe we cannot see it in our daily life, but this one we know in our daily life. We have this, or maybe the other. It can attach to the door of the fridge, and we call that one as a magnet kulkas, or another name for this one is magnetism. So if this one, I think all of us know. So it is one of the application about magnet in our daily life. The next one is this. It is about the card or our kartu ATM, which part of this tool that we use as a magnet, it is below on this card we have the black line. It is consists of the magnet. So in that black line or this chip, this one, we store everything related to our account. For example, username, then password, PIN, balance, etc. is saved in this one. So all of them are the applications of magnet in our daily life, starting from very tiny things that we have like tempelan kulkas, or in high technology like in maglev or this cup. And all of them we will discuss it in our second chapter, which is magnetic fields. So what we will do, we will describe magnetic field as a field of force and use field lines to represent a field. Then we will determine the magnitude and direction of the force on a current carrying conductor in magnetic field. Then we will define the magnetic flux density and describe how it can be measured using current balance. And the last one, we will explain the forces between current carrying conductor. So before we jump to the next discussion, kindly open your classroom in Google Classroom. I already put the edPuzzle video in there. Watch and solve the questions. It is 2 minutes video, so you can work on that one. I'll give you time to work on that one. Thank you for submitting your edPuzzle video through Google Classroom. From the video, we can understand that maglev working using the magnet, or in specific term, it is magnet coming from the electric current, or we will discuss it as the electromagnet. And then we will define one by one the terms that we will use in this magnetic field. The first one, the magnet itself. The magnet track iron containing object like a paper clip, peniti, etc. And the magnet having two poles, the north poles and the south poles. And we will discuss more about the behavior between these poles. And the condition for the poles is like poles will repel, for example, north pole meet with north pole, in short distance there will be repel. And unlike poles will attract each other. North meet with south, they will attract each other. This one condition for the poles. The other we will talk more about that one. The second one, we will define the magnetic fields. The magnetic field itself, it is a region in which magnetic force can be detected. For example, if we have magnet here and we have paper clip. If the paper clip attracted by the magnet, so in this paper clip still in the magnetic region of this magnetic field. If we move away, still it can be attracted by the magnet. And if we pull away more than that one, so maybe it will be not attracted by the magnet because it is out of the region that we call it as a magnetic field. The magnetic field, we can draw something like this. We can use the compass to draw the magnet, something like this. And if we take a look closer to the magnet, so N is north, S is south. Magnetic field coming from north poles to south poles. So it is coming out, and south it is coming in. So from that one, we can understand from the electricity, when we have positive and negative terminal, something like that. So here in positive we have north, and in negative we have south. So this one is positive, this one is negative. So it is coming out, and south is coming in. This is the condition for the magnetic field. And then we can produce the magnetic field using two ways. The first one using the permanent magnet, and the second one we can use electric current, as we seen in the maglev video. And the one that made by using the electric current, we call that one as electromagnet. So electromagnet, we can make it as a coil or solenoid to make it having strength than regular magnet. We can put the core by adding the ferrous of material, something like that. And then we discuss about this one, the magnetic field coming from north pole and goes to south pole. This magnetic field will not cross each other, and if the field is closest together, mean if the magnetic field lines closest together, mean we have the stronger magnetic field for that one. Okay, then we'll discuss it about the magnetic field, and yeah, it is the condition for the magnetic field lines. The magnetic field lines are circular. If we have current carrying wire, it is centered on the long current carrying wire. And all the magnetic field are created by the moving charge. If it is wire, the moving charge coming from the free electron, and if it is permanent magnet, the moving charge coming from the movement of electron within the atoms. It is the example, some of example, the magnetic field that we can see in our daily life. We use the iron filling, and the pattern that we got, for example, the first one, here it is coming from only one magnet. And this one, because attract each other, so we can say that this one coming from unlike poles, and here they repel each other, so this one coming from like poles, something like that. Maybe it is north and south, maybe this is south and south, or north and north. This one is different, north and south, something like that. So it is in our daily life, we can see the magnetic field lines coming from the magnet by the aid of iron filling. In figure below, we have more clear because we make it with the help of the magnetic field lines. For example, here, if we have north and south pole, so from north will coming out the magnetic field lines, and south will coming in, and that's why it will be attracted each other. So north coming out, south coming in. And then if we have something like this, north meet with north is coming out, the direction of the magnetic field lines. This one also north is coming out, so there will be no match here. That's why it will be repel each other. So again, the magnetic field lines coming from out, coming from north, and will goes to south pole. Here we have solenoid as well, coming from north to south, and here we have a loop, also the same. We will discuss more about solenoid and loop later. And then for the unit of magnetic fields, the symbol for the magnetic field is D, and the unit is in Tesla. Another one, Tesla is the common name that we use as the unit of the magnetic field, but it is coming from Newton per ampere meter. Newton per ampere meter. Or another one is, it can be Weber per meter square. Weber per meter square. We'll discuss it in flux later, inshallah. So the unit of magnetic fields in Tesla, the symbol is in B. And the direction, we will use it more when we discuss about the electric current flowing into the conductor. So the field direction, we discussed that the field direction is coming from north to south, but it is a convention. It is a convention, like we have electric current coming from positive to negative. It is also convention. But more clearly, we can take a look in right-hand rule or right-hand rule. Simplify R is R. So right-hand rule states this one: the thumb will represent the electric current, and the other finger, the forefinger, will represent the magnetic field. So thumb, electric current, another finger will be magnetic field. So in electromagnet, most probably, we will discuss about the B, the magnetic field, and also the electric current. We'll talk more about that one. For example, here we have current carrying wire A and B, the electric current I coming from B to A. So use your thumb to represent this one. Thumb is coming up, and then the forefinger will be rounded, will be circular in region of this current carrying wire. If we take into dimension, remember we have dot symbol and cross symbol. Dot is out of paper. Out of paper means coming to us, and then cross is into the paper. So coming to the screen. So if we take a look from A, here is view from A. A is so the current is coming to us out of paper. Then the magnetic field will be in anti-clockwise or counterclockwise. Use your finger, practice it. And then if we view from B, so the electric current is coming into the paper, then the magnetic field will be the magnetic field will be clockwise, searah jarum jam. Also, if you want to practice more, for example in solenoid or loop, we will discuss it later. If in solenoid or loop, better if we use our thumb as the magnetic field and forefinger will be in the electric current.